Welcome back. This is a deep dive into the Spike Prime 3.0 demo. We're going to be specifically going over all of the steps of the Init settings my block. We're going to start by looking up here. If you look up here, this is the typical program starts. Turn off pixels, basically turn the screen off. Run Init settings, which is right here. And then we're going to run mission 1. You should have seen mission 1 run. You've seen all the missions run, well, mission 1 run, in the demo of showing how that worked. That video is up on YouTube. So we're going to kind of go through a deep dive of Init settings so that we can you can learn what kinds of things you're going to need to do if you have to make any changes to this code. All right. So we start with Init settings. First thing is set your angle to 0. Essentially what that's doing is it's changing the yaw, whatever angle you are at that moment, it's going to be set to 0. So it's going to start with essentially straight ahead is 0. Just as a review, the yaw only is good for 180 degrees plus or minus. Minus is to the left, plus is to the right. If you go past 180 degrees, the thing is going to start spinning around. You can play around with that and go try it. The next thing is we're going to set the wheel circumference, the drive wheel circumference. If you remember from your math, the circumference is the pi d. It's the amount of space or the amount of distance that's covered in one wheel revolution. Okay, one wheel revolution. We have measured the diameter of the wheel, and it was 2.2 and change inches. We multiply that by pi, 3.14, blah, 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 blah. Actually, the extra digits are important, so that's why they're there. So why is it not 2.2, blah, 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 blah? It's because with a little bit of tweaking, 2.3 actually worked much better for short distances, and we'll talk about that later. Or in another video. So the wheel circumference 2.3. Now the next thing we're going to do is take the wheel circumference, divide it by 360, and the reason we're dividing it by 360 is the encoders on the robot are set up so that they will give you units based upon degrees. Okay, accumulated degrees as I drive. If I roll the wheel over twice, I'll get 720 double 360 degrees. Well, we calculate how far we go, distance per degree, by taking the wheel circumference divided by 360, and that's how our code figures out how far we went. Okay, the next is adjust drive and adjust gyro. These two values are used in the code that we're actually driving. Gyro drive by distance specifically, and gyro drive just distance specifically. What they do is they adjust how the calculations are done, giving a little more weight, for example, to things. Adjust drive is set to 1. The idea is that if you have a robot where everything is reversed, adjust drive, if you set that to -1, will essentially flip the power. Okay, we use that a lot in the big robots. It is in here. I have not really tested it, but that's its purpose. So I would leave it as 1 and try to get the thing to go in the direction you want to go with the model the way it is. Okay, adjust gyro is a little different. We're going to talk about adjust gyro in another video when we do a deep dive on the gyro turn to angle method, and that's where this is used. But essentially, gyro adjust, right now it's set to 1 because it's a multiplier. So if I say I am off by 2 degrees while I'm driving with the gyro, we multiply that by gyro adjust or adjust gyro to get our correction of what we have to do. If we leave it at 1, then whatever the correction is that we have, we leave it. But if you have a robot that has something on it that is dragging the robot, you might need to make that a little bit higher to help it get there. Okay, and that's what adjust gyro is. Then we have gyro turn speed min and gyro turn speed max. Gyro turn speed min, normally, I'm going to reset it right now, is set to 3. And so again, this has to do with turning, and this is specifically used in the gyro turn to angle. That's the method that actually sits there and just turns the robot to the angle that you want. These are actually going to be the speeds that you're going to run at. The gyro turn speed min is 3 in this case, and it means if you're so close to the final angle that you want to be, you might have a calculated proportional correction that's too low for the robot to actually move. So in that case, the 3 is going to get used. So if the correction is less than 3, then the correction will be set to 3. It means we're going to use a power of 3% of the motor to get it to where we want to go, whether it's minus or plus. Right? So imagine the robot is struggling to get to that point. You can up that number. And I've tested that number up to 6, and it works fine. If it's too high, the robot may go back and forth trying to correct to the angle. But that's what this is for. The second one, gyro turn speed max. Gyro turn speed max. The purpose of gyro turn speed max is to limit the amount of correction for the gyro turn to angle method only. What we have discovered is turning too fast, all of a sudden we run into problems with the gyro. It has a tendency to get messed up. So this prevents that. It turns slow and then boom, off it goes. Once it's on the angle, it takes off. All right? So these purple things are motion. You can see movement up here. See movement up there? Well, that's where they come from. These are the things that are used by the system when it wants to do some of the things we're doing here with our tools. So set one motor rotation to drive wheel circumference in inches. Okay, if you look here, it could be inches or centimeters. We're set to inches. To inches moved. One of the things I like about this is it's very clear what we're getting here. Set one motor rotation to gyro wheel circumference in inches moved. Okay? The other thing we're going to do is set movement motors to A plus E. Now we can look here. It should give me, hang on. So this is a cool one. This is the thing that they use. Here we go. It shows me the motors. If you know from the demo disclaimer that should have been in the beginning of this document, this thing, we set the drive motors to the left motor to A and the right motor to E. If you have a different setting, you have to go change this to go set your motors. Okay, but this is where we would set the motor movement, so that's how the system knows which is the left and right motors. Okay, drive motor measure. In other words, which drive motor are we using to say that is the drive motor that we're looking at to measure the distance we've moved? In this case, I have it set to E, which is the right motor. Okay. Line waypoint sensor is set to B. Now, the waypoint sensor is a way of saying I want to use a light sender to say if I cross this line, I'm to stop. Okay? It's not like line following, but it just says if I see this black area or dark area on the screen, I know I've gone far enough, I want to stop. In this case, we're setting that sensor to B. That is actually not used in the demo because there's no 2 line sensors on there. There's only 1. Okay. Line follow sensor is actually here set to D. That's incorrect. It actually is F because I had you rewire that. Okay. Now, why is it that I can correct this and not screw anything up? Because I didn't use any of the line sensor stuff when I was setting up this demo. I've only used gyro. I may do a line sensor thing for this release, but I'm not sure that I need to because I think the other settings work fine. You just have to bring the 2 dot over into the 3 dot over world. Line midpoint reflectivity. This is essentially a setting. When you're doing line following, you're going to tell the sensors, I want you to reset yourself to do reflectivity, not color. Okay, and what will happen is the sensor will look at the lines and see the light coming off of it. 40, think about 40 being a somewhat midway between a light area and a dark area. Usually I think it's down in the 30s, but right now, so you know what, we'll even reset it. Just so you know, I'm going to reset this to 33, because that was a number that I was actually using the last time I was using this. But that's what that's for. That is used in the line follow stuff. That still is in there, but I really didn't test it a lot. So I prefer actually to use Gyro, so that's why I didn't do it. Now the final one is specific to this new robot, and you can add all your own settings down here. So here's the different, so the C motor, which is, is actually plugged in the back of the robot on the demo robot. It's in the back of the robot. It's between the A and the C. So what are we saying? Set relative position to 0. So as you pick this robot up and turn it on, the degrees are going to change. So it might be at 240 degrees. However, you're setting a separate value that says, okay, I want to set the relative position to 0. That's relative to position. Relative position. It's not what actually is on the encoder, but it says, okay, we're starting from here. Starting from here. So now when you move forward and you want to say, go get the value, you can then go read it. Oh, I just realized I have this in here twice. Let's delete that. We don't need it, but it's not hurting anything. Okay. Now, set motor, C set motor, hold position at stop. Okay? We did that because we want to make sure that this is the motor that's being used to pick the plate up and down. All right? It picks the plate up and down. And what we want to do is when we say stop, we want it to go into a hold position. This is specifically true when it's up, but it's not so necessarily true when it's down. Okay? And if you watch the video on moving the plate, you'll see some of the things I do in there reset this. But this is how we have it originally set. Okay? All right. Well, that's it. That's setup. That's the Init setup for this project. You can go in and change all of these values. You can do whatever you want with them. But understand that some of these, like these, and those down here, and these up, well, these up here, we use these values to help us turn as well as get our distance when we're running. All right. Good luck, and hope you have a great season.